For problem number 2, first thing we want to do is recognize that we have a piecewise function. Of course, it says that here. Piecewise functions mean that we have to split up the domain into domain restrictions. So the domain restriction for the first piece, second piece, and third piece, I'm going to indicate that by putting 3 commas. So I'm going to put the value of the function to the left of the commas, and I'm going to put the domain restrictions to the right. So if I identify the domain restrictions to the right first, then I can focus only on the actual equations for each of these lines as if they went on forever. So the first domain restriction, if I interpret this first one as going on forever to the left, then I would say, since this x coordinate, x value here is -1, so -1, this first piece would be for all the x values to the left of -1. So the open circle there means to the left of, not including -1. So the first piece would be for all the x values that are less than -1. The second piece would be defined for all the x values between -1 and 2, not including -1, but with this solid circle there, solid dot, it would include x equals to 2. So we would say from -1 to 2, and the way we do that is we write -1 is less than x, which is less than or equal to 2. And then the third piece, again, going to assume this goes on forever to the right. This third piece would be defined for all x values greater than 2. So x is greater than 2. So we take care of that, and now we can just focus on finding the equation of the line. Just like Math Easy said, to find the equation of the line, you have to have the line there, and then you plot 2 points, label them both. Plot 2 points, label them both. And so get the slope, it shows the growth. So we want to find coordinates that are right on the vertical and horizontal lines where they intersect. So it looks like that. It's not a perfect science, but that's looking pretty convinced that the slope of this line is up 3 and over 1, so -3. If we plot 2 points and label them both, then we can do it that way, but we can also just count. So I'm seeing a slope of -3, down 3 and over 1, or up 3 and to the left 1. But if we follow that Math Easy wrap, then we have -3 for the coordinates of this point, -3, 11, and the coordinates of this point are -2, 8. And if we want to find the slope, then we get the difference in the x and the y coordinates first, 11 minus 8, over -3 minus -2, which is 3 over -1, which is -3. So we have a slope of -3. And then if we put the slope and a point in the point-slope form, we can solve for y, and then we'll have our equation. We could also do this. We could also find a y-intercept. So if we take this point here, we go down 3 and over 1, we see it would cross the y-axis at y equals 2. So actually, we know that the equation for this piece is y equals -3x plus 2. But let's say you didn't think of that. Let's say you took the slope and you took a point. So I'm going to take the point -2, 8, and I'm going to put the -2, 8 in the point slope form. And so we take y minus 8 equals slope times, and I should put this here, y minus y1 equals slope times x minus x1. That's the point slope form. And so we take the point -2, 8, and we write 8 as the y1. We write -2 as the x1, and x minus -2 is the same as x plus 2. Solving for y equals, getting rid of the parentheses, -3x minus 6. If we add 8 to both sides, then we get y equals -3x plus 2, like we talked about a little earlier. So we can do it the long way, or if you can see some shortcuts, you can also do that. So if you can identify the slope and look and see where the line would cross the y-axis, you can find the slope and the y-intercept, and you can do it a little bit quicker. So the equation for the first piece is negative 3x plus 2. That's the first piece. The second piece, let's do it the short way. Identifying the y-intercept as 3. So the y-intercept is 3. So for the second piece. And then let's try to find the slope just by counting. Up 2 and over 1, up 2 and over 1. So we see the slope is 2. So we know that y equals mx plus b, and m is 2, and b is 3. So y equals 2x plus 3. So that's the value of that piece, 2x plus 3. And then finally, the equation for this line here, since that's a constant, the y value is always 1, 2, 3. So if the y value is always 3, then the value of the function would be 3 for the piece from all the x values that are greater than 2. And that's it. That's our piecewise function. The value of the function depends on the x that you're using, the domain values of x. So we have the domain restrictions, and we have the value of the function for each of those domain restrictions.